The eighth question that we have is a very important question. It is given that a sound source is moving with velocity vs towards right, and here we have an observer who is stationary at this point. We need to find out the frequency observed by the observer O when the source is at point P. Now, the most important thing you should realize in this question is that the frequency observed by the observer O when the source is at point P will not be due to the wave emitted by the source when it is at P. It is due to the wave emitted by the source when it is at some point at distance x. Because in the time that the source takes to travel from here to here, in the same time sound will travel from here to here, and the frequency which it will observe due to the wave produced over here will be equal to the frequency observed when this source reaches the point P. So let this point be at a distance x. This is the point corresponding to which the wave reaches point O when the source reaches this point. Let this distance be equal to L. Therefore we can write x upon Vs, that is the time taken by the source to reach from here to here. This is also equal to the time taken by the sound to reach from here to here, that is L upon velocity of sound. Therefore we get L upon x is equal to V upon Vs. The important thing is that at this point the source had a velocity in this direction. That is, the velocity of source was not in a direction towards the observer. We already know that if we have a source moving at speed Vs towards the stationary observer over here, then the wavelength is equal to V minus Vs into t. But this is the case only when the velocity of the source is in the direction of the observer. Now since the velocity of this source is not in the direction of the observer at this point of time, therefore we have to take the component of velocity which is in the direction of the observer. So let this angle be equal to theta. We can write that the frequency observed by the observer is equal to, you can always use this equation to avoid confusion, lambda observed into velocity observed into frequency observed by the observer is equal to velocity of sound with respect to observer. You should remember the formula in this format to avoid any confusion in Doppler effect. This is similar to the formula lambda f is equal to V. It is just that lambda observed by the observer into frequency observed by the observer is equal to velocity of sound with respect to the observer. So using this formula we write f observed will be equal to velocity of sound with respect to observer. Since the observer is stationary, the velocity of sound with respect to observer is V, divided by the wavelength observed by the observer. The wavelength observed by the observer will be the wavelength emitted by this point in this direction, that is V minus Vs cos theta into t. This t is equal to 1 upon f, that is the frequency with which the sound source produces sound. Therefore this can be written as 1 upon f. So f will come over here. Therefore f observed comes out to be equal to f into V upon V minus Vs cos theta. Now this cos theta is equal to x upon L. Now this x upon L is equal to Vs upon V as we had found out earlier. Now substituting cos theta is equal to Vs upon V, we get f observed is equal to f into V upon V minus Vs into Vs upon V. Therefore this becomes V square upon V square minus Vs square into f. So our answer for the frequency observed by the observer comes out to be equal to V square into f upon V square minus Vs square, and this is our final answer.